Bismillahirrahmanirrahim. Today is our second lecture of course Calculus 2. In today's lecture, we will study limits. Basically, we have studied limits in Calculus 1 by taking the limit of one variable. We have seen that when we approach the one point from the negative side and from the positive side, if we reach at the same point, our limit exists, and otherwise our limit does not exist. So now we will solve for two variables, and the important thing is that we will also see that when we approach from the different points, should we reach at the same point or not. So by starting from our first question, limit x and y, because in calculus 2 we are taking two variables, approaching 0 0, x y4 divided by x4 plus y4 exists. हमने ये बताना है कि हमारे पास ये लिमिट एग्जिस्ट कर रही है या नहीं कर रही. So for this we are taking, first of all we will see that along x-axis does this limit exist or not. For this we will take y equal to 0, but at the place of x we will put as it is its values. So we will write it as limit y approaches 0, x y4 divided by x4 plus y4. Now we will approach the limit. So x into 0 raised to power 4 divided by x4 plus 0, which means 0 divided by x4, and 0 over something is 0. Now along y-axis we will take x equal to 0. So same limit, x approaches 0. Our expression is xy4 divided by x4 plus y4. Now we will put the 0 at the place of x and the y values remain same. So 0 into y4 divided by 0 plus y4, which means 0 by y4. That 0 over something is 0. Now in calculus 1, by solving such conditions, we can say that our limit exists. But now we also have to check along all paths. This is our first point, this is the second one, and on the third point, we should check along y is equal to mx, which says that approaching the same point from all paths. So if in this case we will get the answer 0, our limit will exist. But if our answer is not 0, our limit will not exist. So we have to put y is equal to mx at the place of y, but the values of x will remain same. So x y4 divided by x4 plus y4 limit. What is our limit? That y approaches mx. So x into mx raised to power 4 divided by x4 plus mx raised to power 4. By multiplying the x inside, we will get m4 x5 divided by x4 plus m4 and x4. We can take the x4 common, x4 into m4x. Why we are taking x4? Because in denominator our biggest value is x4. So we can take the denominator, we can take the common from the numerator and denominator, and so we can simplify it. At the place of x4 it will be 1 plus m4. Now x4 will be simplified and we will get m4x divided by 1 plus m4. Now here is one important point, that when we solve an expression and we get an independent variable, after solving it, we will put the independent variable equal to 0. So in this condition, our independent variable is x. So we will solve it. Limit x approaches 0, m4 divided by 1 plus m4. x. At the place of x, we will put the limit which says 0 divided by 1 plus m4 and it will be equal to 0. So we can say that limit exists. Because in all our three conditions, we are getting the same value, we are reaching at the same point. Now this is our one more example. In this we will see that if our limit exists or not. So for this, we will solve it the same way we have solved the example 1. By starting from our first point, that along x-axis, what is our condition? That y is equal to 0. So limit xy divided by x square plus y square, in which our limit is y approaches 0. So at the place of y, we will put 0, x square plus 0. 0 by x square and 0 over something is 0. So on the second condition, that along y-axis, our x is 0. So limit x approaches 0, xy divided by x square plus y square. So now we have to put the 0 at the place of x. So 0 into y divided by 0 plus y square, which says 0 over y square, which is equal to 0. Now our third point is along all paths. That if we approach from the all paths, should we reach at the same point or not? For this we will take y is equal to mx. Limit y approaches mx, xy divided by x square plus y square. Now at the place of y, we have to put our limit, which is mx. So x into mx divided by x square plus mx whole square. Now multiplying x inside, we will get mx square divided by x square plus m square x square. We can see that from numerator and denominator, we can take the x square common. X square m divided by x square into 1 plus m square. X square will be simplified and after that we will have m by 1 plus m square. So now we can see that along all paths on the third condition, by putting y is equal to mx, our answer is not 0, which is on the first condition and on the second condition. So we can say that in this question, our limit does not exist. We can put m equal to 1, 2, 3, 4 or any value. So by putting the different values of m, we will get the different answer. We get the different values. So we can say that our limit of this function will not exist. Now we will solve one more example of trigonometry. So for this, we are taking our question, that is limit x and y approaches 0, 0, and we have to check on the function. Our function is of two variables xy, which says x y square cos y divided by x square plus y4. This is square. Okay. Now we will solve it on the same pattern. On our first condition is along x-axis. For this, our condition is y is 0. So now at the place of y, we have to put 0. But first of all, we will write it as limit y approaches 0 and our expression x y square cos y divided by x square plus y4. So at the place of y, our value is 0. 0 square cos 0 divided by x square plus y4. So because of this 0, our numerator whole is 0 divided by, okay, at the place of y we have to put 0. So this is only x square. 0 over something is 0. Now for the second condition, along y-axis, x is 0. So for this limit, x approaches 0, x y square cos y divided by x square plus y 4. Our x will be 0. So 0 into y square cos y divided by 0 square plus y 4. Our answer is 0 by y 4. 0 or something is 0. Now we have to check along all paths. So if our answer will be 0, so we can say that our limit exists. But if our answer is not 0, our limit will not exist. For this, our condition is y is equal to mx. So limit y approaches mx, x y square cos y divided by x square plus y 4. X, at the place of y we have to put mx, mx square cos mx divided by x square plus mx 4. We will take the x square common. We are taking x square common, so our value will be mx cos mx divided by x square into 1 plus mx m4, and x square will be common, so it will be x square. Here we have m square. Okay, we are taking the x square common, this one x and the one from this x square. So this x will be simplified and we will get m square x cos mx divided by 1 plus m4 x square. Now an independent variable is existing. So our next limit will be limit x approaches 0. M square x cos mx divided by 1 plus m4 x square. So at the place of x we will put 0, m square into 0 cos m 0 divided by 1 plus m4 x square. Our answer will be 0. Okay, m4 0. Our answer will be 0 by 1, and 0 or something is 0. So in this condition our limit will also exist. This is also very important and different from the other questions. In this our limit xy belongs to 0 0. Okay, so this is our question. In this we are having something different. This is something different which was not in the previous question. So we define it as xy is equal to plus minus xy, which means now we are having two cases, that xy is greater than or equal to 0 for the positive one, and for the negative case we will have xy is less than or equal to 0. So for this, we will solve such question as by taking the case 1, which says that xy is greater than or equal to 0, which means limit xy approaches 0 0, and we will put the positive value at the place of xy because we are taking the xy greater than or equal to 0. All the values will be positive. So 2xy minus x square y square by 6 divided by xy. For this we will take the xy common. We will write limit xy approaches 0 0. Now to simplify this expression we are taking the xy common from it. It will be 2 minus xy by 6 divided by xy. This xy will be simplified. We will get 2 minus xy by 6. As our limit is xy approaches 0 0. So for this, when we will apply the limit, we have to put the 0 at the place of x and also 0 at the place of y. So it will be 2 minus 0 at the place of x and 0 at the place of y divided by 6. It will be 2. minus 0 by 6, it will be 0 over something will be 0, and our answer is 2. Now for the case 2, we will take xy less than or equal to 0. In this condition, we will put the value minus x, y, minus xy. So limit xy approaches 0, 0, and we have to put the negative value, so 2 minus xy minus x square y square by 6 divided by minus xy. Now we will take the minus xy common from the numerator, so it will be minus xy common, and our expression will be 2 minus xy by 6. As we are taking the minus common, so here we will have the plus divided by minus xy. Minus xy will be simplified, and we are left with 2 plus xy by 6. Now when we will apply our limits, at the place of xy we will get the 0. So 2 plus 0 by 6, 0 over something is 0. So for this case, our limit will also exist. We are having 0 as our limit. We are approaching the 0 on both cases, on the negative xy and on the positive xy. So this was our second lecture of course Calculus 2. In our next lecture, we will solve continuity.